This is the New York State Test. This is the year 2024, and these are the release questions by the New York State Education Department. Let's get started immediately. Here we have the first session, session 1, and this is 8th grade and the year 2024. Let's get started immediately. Let's go over problem number 1. As you can see, problem number 1 is about a group of friends who went to a movie theater and they pay $15 for each ticket, right? For each ticket to enter and see and watch the movie. The group of friends share one container of popcorn that costs $8.99. Then the question is asking us, which equation can be used to determine the total cost, C, for N tickets and the container of popcorn? This equation is pretty much going back to the main concept that you guys learned in 8th grade about the equation of the line. Y equals mx plus b. In reality, it's plus or minus, but let's keep it like that, right? Mx plus b. Where we know that m represents the slope and b represents the y-intercept. We also know in 8th grade we learned that this equation not only represents lines, it represents a function, it represents a situation, right? What is actually happening. And here in the text, we have some keywords that we need to highlight and understand. The first keyword that I see and can spot immediately is the word each, right? Each what, by the way? Each movie ticket, right? Because there is a movie ticket that each person paid. So each movie ticket costs $15. And it says right here that they share, right? They share one container of popcorn. It was shared. It was not something that each of them bought. It was one container for all the group of friends. Therefore, if it says each, right? Each movie ticket, this is how much each person paid. Therefore, we don't know how many people pay that, right? So in this particular case, X will be representing the number of people, right? The number of persons, right? How many people paid, right? The number of people that pay for the tickets. And M, the slope, right, is the cost, right? The cost that each of them paid. Then what will be the y-intercept? This is something that I always like to remind students that the y-intercept is something that you pay once. It is something that you pay one time, right? Only one time, once or one time. These are keywords for you to remember that the y-intercept is only one time payment or once. Therefore, based on this information, we need to create our equation. Which one will be our equation? Well, C will be equal because C is the total cost. C for cost, right? This is abbreviation for cost. The total cost will be equal to what? To whatever they pay per ticket, which is 15. Now the tickets are not going to be represented with X. The tickets are N tickets, N amount of tickets, the number of tickets, right? So 15N, because $15 is how much each ticket costs, and N is the number of friends. And then there is a one-time fee, right? There is a one-time fee, one-time payment. What is that one-time fee? That one-time fee was the $8.99 that the students paid for the popcorn that they shared. And this is pretty much the equation that represents this particular scenario. So therefore, our answer will be A. That is our answer, A. Let's move on immediately. Let's go to problem number 2 now. Problem number 2, we have a scatter plot here, which is pretty much taught in Unit 6, but it depends on the curriculum. So here we have a scatter plot. The first thing that you notice when you see a scatter plot is the trend, right? What is the trend? If there is any trend. So this trend, remember, we talk about it in 3 different ways. It's either a positive trend or a positive what? A positive association, right? A positive association is either a negative, right, trend or a negative association. Negative association. And then we also have zero association, right? Or none, right? There is no association at all. Zero association. So we have these 3 different scenarios. So in this particular case, as you can notice right here, we definitely have a positive trend. We have a positive association because we can see how the values in the x-axis are increasing and also the values in the y-axis are increasing. Therefore, I can easily, with a ruler of course, draw a line of best fit right here through most of the points, in the middle of most of the points, in the center, right, close to all the points. So I can see that I have a positive association. That's the first thing we need to identify before we go and work on the problem. Now, we have a set of points here. We have a bunch of points right here, and we need to understand which of these points can be used in order for me to find the representation, right? It says which pair of points could be used to draw a line that best represents the relationship of the data. So this line has a slope, correct? Remember, this line is in the same format, y equals mx plus b, right? Y equals mx plus b. So we're trying to find and identify what is the slope, right? What is m? What will m be? We know that m is positive, correct? So whichever we use here must be giving me a positive slope. Therefore, what we do in order for us to find the slope here, to find out what is the line that could be used here, we need to do the following. We need to identify where the points are. 4, 7. So 4, remember, the first one is the x value and the second is the y value. Same thing for all the points, x and y. So 4 in the x-axis, so I go to 4 in the x-axis, this is x. The first number is x, they go in alphabetical order, remember? X, y, z. So x is 4, and then in the y-axis is 7. So you go all the way up to 7. And it's telling me that I can use this point. Do you think we can use this point to find the slope of this line? We can also check the next point, 8, 4. 8, 4. So if we use these 2 points right here, if we use this point, and we connect these 2 points, pretty much we are going to find the slope of this dotted line that I am doing right now. Do you think this is going to work out? Do you think this slope is representing this trend? I think not, because definitely you see that this is going down. This is going to give me a negative slope. So we need to pick points that are in the same orientation or near the line, right? The points need to be in the same orientation, one lower, one higher. So let's find out with the second one. Let's see what happens with the second one. 3, 3. 3, 3, right here. This is the point. I'm going to put it in a little square, right? 3, 3, that's my first point. And the next point is 9, 7. Let's go to 9. Let's go all the way to 7. Okay. So you see, if I use these 2 points, do you think that I will find the slope of this line? I believe so. This is the points that we need to use, because if I draw a line connecting these points, right, this line will look like this. You see it? This line will be looking like this, and therefore is the same trend of the original line that I draw for you to see. So you see, I did a little dash, 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 so we can identify it better. Now, how I am also sure of this, right? I know this is my answer because these are the points that are like that. We can check the rest. We can check 2, 4. 2, 4 is right here, is this one, and also 6, 4. 6, 4. You see, this is going to give me a 0 slope because it's a flat line that is forming these 2 points right here. So we discard that. We discard that because it's negative slope, and then 0 slope. What will happen with D? Let's find out real quick. 3, 2, and right, 3, 2, and the other one was 3, 4. 3, 4. You see, so this connected will give me a vertical line, and therefore I'm going to have an undefined slope, right? Undefined slope, because it's going to give me a vertical line completely up and down. This is giving me a flat line, and this is giving me a line that is going down. So the only one that is giving me a line that is going up is B. That's why this is the correct answer. All right, let's move on right now to question number 4. Question number 4, we have a triangle, right? We have a triangle that is rotating 90 degrees. This triangle is rotating 90 degrees about the origin and then reflected over the y-axis to form a triangle A prime, B prime, C prime. One of the angles in triangle ABC, in the original triangle, has a measure of 115 degrees. So I already know one measurement of this triangle, right? I already know one measurement of this triangle, and one of the angles of the rotated triangle, pretty much triangle A prime, B prime, C prime, has a measure of 40. So when I rotate a triangle, right, any triangle, when I rotate it, it still keeps the same dimensions, right? The same degrees, right? It does not change. Let's say this is a triangle we're talking about. Let's say, so this is an example, 115, and we know that when we rotate this, there is another side that measures 40 degrees. So if I have two sides, I know something very special. All triangles, right? All triangles, well, not all, but most, in 8th grade is all, but most triangles, or all of them, have or add up, right? Add up to 180 degrees. So this is a very basic learning. 180 is the total of the sum. So whatever that angle is here that is missing, that we're looking for, must give me the sum, must give me 180. Therefore, I already got my answer. If I do 180 minus 115 minus 40, I should get how much is the missing side, which is what I'm looking for right here, right? And when we do this with a calculator real quick, we're supposed to get 25. You can do it with a calculator or not, but the answer will be 25 degrees. This is how this is done. All right, let's continue now with problem number 5. In problem number 5, we notice that we have an equation. Some people get scared with this equation because they see decimals, they see fractions, right? And sometimes they see too many x's and too many numbers. And oh my God, this is so difficult. This is not difficult at all. I will show you 2 different methods in order for you to solve this problem. And you pick which one you like better. You know, you don't have to use both of them. You can use whichever method you feel more comfortable with. So let's start with the first method, which is pretty much using the fractions, right? We can keep it with the fractions, and we don't need to pretty much change everything. We simply have to keep the fractions, and then we will get the same answer. So the first step is to decide where do you want the variable. Do you want the variable to be on the left side of the equation? This is the equal sign. You want to be on the left side, or you want it to be on the right side? You decide that. It is no right or wrong way. You can put it in the right side, you can put it on the left side. It's your decision. I will decide to put it on the left side. That's the conventional way. So therefore, if I'm putting the variable on the left side, I need to do the opposite. That's one word you need to remember. Opposite, right? Do the opposite or inverse. Inverse operation, right? You got to do the opposite or inverse operation whenever you're solving equations. Therefore, if I'm taking away 3/5 of x, right, I will add 3/5 of x, and I will do it on both sides. If I do it in this side, I must do it to the other side, right? I must do 3/5 of x in this side. So therefore, this cancels because these are inverse operations. And now let's see what we got, right? Let's see what do we obtain when we perform this operation. We will have 2 over 3x plus 3 over 5x minus 7 is equal to 5 only. You see, it's just equal to 5. Now we need to get rid of the number. We need to move this number to the other side of the equation because I decided to have my variables here, my x. So I don't want to have any numbers here. I want the numbers to be on the right side. So therefore, I am going to add 7 by doing inverse operation and keeping the equation balanced. Therefore, they cancel, and I have 2 over 3x plus 3 over 5x is equal to 12 because 5 plus 7 is 12. Now, here's the moment of the truth. How do you know which what to do, what operation? How do you know how to solve this, right? This is the moment of the truth. Here, I have a very, very nice, unique method. You can use different methods, but this is a method that I believe is pretty easy to use. We're going to cross multiply. We're going to multiply these 2 numbers. We're going to multiply these 2 numbers, and we're also going to multiply these numbers. We create a happy face. Let me show you how that looks. 2 times 5, that is 10. 3 times 3, that is 9. Since we're adding, right, we see I have an addition sign here, so I'm adding 9, right? 2 times 5 is 10, and 3 times 3 is 9. Then 3 times 5 will give me 15, and I put it on there right here. You might be wondering, what happened to the x? Well, the x is still right here because they all share an x, and that is equal to 12. I'm running out of space, but don't worry, I will be able to finish this problem and show you the solution. So right now what I need to do is simply add these numbers and then divide it, right? Let's see what we get, right? 10 plus 9, I will continue right here. 10 plus 9 will give me 19, and the 15 stays here, 15x, and we know that is equal to 12. Now, I'm not finished yet, right? I'm not finished. I need to still solve for x. How do you solve for x right here? How do you solve if you have a fraction? How do you solve for x? Well, we pretty much have to do the inverse operation. We have to multiply both sides by 15 and also divide by 19. And therefore, we will be able to get our answer. Pretty much we're multiplying by the reciprocal of this particular fraction right here. So if I multiply this by 15 over 19, I need to multiply this side also, right? I need to multiply this side by 15 over 19, right? I multiply both sides by the reciprocal of the fraction so they can cancel. As you can see, they cancel, they cancel. Now I have my x by itself, right? I have x. X is equal to what? Now, 12 times 15, right? 12 times 15. X is equal to 12 times 15 divided by, right? Divided by 19, right? 12 times 15 divided by 19, and therefore we are going to obtain our answer. So therefore x is equal to what? To 180 over 19. You might ask, wait, but this is not there. This is not one of the answers. All right, that's truth. This is not one of the answers. But if we simplify this, sometimes the calculator shows you a little arrow pointing down. That means you can simplify more. So you can type this into your calculator and press enter or press simp, right? There is a button called simp, and you can simplify, and immediately you will obtain your answer. Now, another way to do this is by simply dividing. You know, how many times 180 goes into 19? So how many times 180 goes into 19? 180 goes into 19 9 times, exactly 9 times. So I already know that my answer is not A, my answer is not C. My answer is either B or D. Now, which one of the two is my answer? So as I told you, right? X is equal to 9 because it's 9 times, right? 180 goes 19 times, right? Now, if it goes 19 times, if I go 9 times, right? If it goes 9 times, then what is the remainder? What is the remainder that we have? So 180 in reality goes 9 times, and 9 times 19 will give you 171. Therefore, we have 9 remaining. We have 9 remaining. We write it on the top, the remainder, and we still keep the same denominator as 19. Therefore, our answer is B. Let's continue. We have more problems. Let's continue right now. Problem number 7 right now. Problem number 7. So here we have two electricians, right? Two electricians, electrician A and electrician B. And they are offering different pricing plans, right, for their work. Each electrician charges an initial fee for a service call plus an hourly rate. The charges of each electrician are represented right here, one with the equation, the other one with a table shown below. Now, how do we know which of these electricians, right? When we're comparing, which statement comparing this electrician is truth. We're trying to find out which of these statements right here is truth. In order for us to be able to compare these electricians, we need to find out what is the initial fee that they charge, and also we need to find out what is the hourly rate, because these are the key information we see right here, right? Initial fee. Remember what I told you earlier about the y-intercept, right? Let me write it again. Y equals mx plus b. And I told you earlier that b, which is the y-intercept, as you recall, you can go back in the video if you wish, is a one-time payment, right? One time or once, or one-time fee. Remember that? So the y-intercept is a one-time fee. We're trying to find out what is that fee right here. What is that fee? What is that fee that each electrician is charging? And we are also trying to find out what is the hourly rate. For the equation for the electrician A, this is a very straightforward problem, because the hourly rate, right, it goes per hour. That's the keyword, right? Hourly rate means it is per hour that they charge, right? So if I am charged per hour, which of these is showing me that is a charge per hour? The 25. So it means that this electrician is charging me $25 per hour, right? It charges $25 per hour. This is per hour. Therefore, the one-time fee, right? The one-time fee that we charge, the initial fee, will be the $50. This is the initial fee right here. So we already got the most important information that we need to compare electrician A. We got the how much this electrician charges per hour, and we also have the initial fee of this electrician as well. Now we need to find out with electrician B. There are many ways for us to do this. But the shortcut is, in order for you to find the COP, the constant of proportionality, or the slope, another name, right? The slope is to divide y over x, right? I need to divide y over x to find out if I have the same rate, to find out if this table is has a constant of proportionality. Well, we can see here that it goes from 130 to 150, so increases 20, and then from 150 to 170, also 20. Okay, that's a good pattern. And here it goes from 3 to 4, so it increases by 1, and then from 4 to 5, so increases by 1 as well, right? Okay, now if I always need to consider this, remember, always, this is a conventional way, always. This is representing x, and this is representing y. This is representing x, the first column represents x, the second column represents y. Therefore, let's divide it. Let's find out how much are we going to get if I do that, right? Let's see how much I'm going to get if I do that. If I divide y over x, I may get my constant of proportionality, but in this case, I do not know what is the initial fee, right? I do not know what is the initial fee, so we need to make sure that we find our initial fee. We know it's increasing by 20, right? Every hour is increasing by 20. Therefore, this is the rate per hour, right? This is per hour. This electrician is charging 20 per hour because it's increasing by 20 every hour. So every hour increments. So if I do 6 right here, therefore this will be 190 because it must increase by 20, right? If I do 6 hours, it will do 20 more, 190. So we have some evidence here. We know this electrician charges $20 per hour. But now what I need to find is what is the initial fee of this particular electrician? What is the initial fee of this particular electrician, of electrician B? How do we find out what is the initial charge of electrician B? Well, we can use this formula, the formula of the line, y equals mx plus b. We use this value right here, the $20 per hour, and we're going to use one of the points in order for me to find this particular value. So what we're going to do right now is to use this point, any of these points, with the amount that this electrician charges per hour, in order for me to find out what is the initial fee that this electrician charges. Let's do it. All right, let's get it. So I'm gonna need some space in order for me to show you how to do this. So we're going to use the same equation that we have, but we already know that this electrician charges $20 per hour. So I'm gonna write 20x plus the initial fee, which we don't know, right? This is the one that we're looking for. We don't know, right? We don't know what is the initial fee. That's what we're looking for. So in order for us to find out, we need to use any of these points. So let's use the first one, right? Real quick. 130, right? For 3 hours, it charges $130. So this is always representing x, and this is representing y. I hope you can see it, right? This is representing x, and this is representing y. So we're going to simply substitute. We're going to plug in these values in here in order for me to find out what the initial charge is. So instead of writing y, I'm going to write 130. Instead of writing 20x, I'm writing 20 times 3. And then I'm adding the b because that's what I'm trying to find out. What is the y-intercept? Where does this electrician start charging? If I multiply 20 times 3, I will get 60. right? I will get 60. And if I want to solve for b, I want to isolate it, I need to do the opposite operation. You know, there is a little trick right here. This is an invisible positive, right? Because we know this is 60 and we know it's a positive number. So we need to do the inverse operation, which is subtracting 60. We need to subtract 60 because there is an invisible plus right there. So this is inverse operations. They cancel each other. I bring down my b. I bring down the equal sign. And therefore, I do 130 minus 60. And that will give me 70. And this is the initial fee. So we have found the initial fee for electrician B. Now, let me explain something real quick, because there is another way that we can do this as well. So I know 3 hours is 130. But what about if we try to go backwards? If I reduce 1 hour, right? If I reduce 1 hour, so it's going to be 2 hours now. What do I need to do with this? Do I need to add 20 or subtract 20? Correct? So we subtract 20 and that will give me what? 110. Correct? 110. And then if we go back again 1 hour to 1 hour, and then we go back again 110, that will give me 90, which is slightly different. That's supposed to be 70, but it's 90 because we are in 1 hour still, right? It's not supposed to be 70. I'm sorry. It's supposed to be 90 because in 1 hour he charges 90, which is the 70 of the initial fee and the $20 of the first hour. We need to go to 0. Let's go to 0. If I go back again to 0, I need to go back again and reduce 20. Therefore, for 0 hours, the initial fee is $70. For 1 hour, he will charge $90. For 2 hours, 110. 3 hours, 130. And you can see the pattern going on. Now, let's go to the answer now because I explained the problem. Here we have a lot of statements. We have 4 different statements here. We need to pick the right statement. Which of these statements, right? Which of these statements are truth, right? We need to find out which of these is truth. So electrician A has an initial fee and an hourly rate that are both less than those of electrician B. Let's find out. We know that electrician A has an initial fee of $50 and the hourly rate we know is $25. Is this both, right, than those of electrician B? Well, we know that electrician B charges what? Charges 20 per hour, and charges 70 as initial fee. 70 as the initial fee. So is this a statement truth? It's not, because in reality this electrician A, right, does not charge both of them lower than this one because the hourly rate is higher. So we discard this one. It's not A. Let's go over B right now. Let's see what is B. Electrician A has an initial fee and an hourly rate that are both greater than that. Let's see. The initial fee is 50. The hourly rate is 25. Are these numbers, the initial fee and the hourly rate, greater than the one in B? Well, we know that B charges 20 per hour. So if this one is charging 20 per hour and this one is charging 25 per hour, that's not truth. Because, well, that's truth for the hourly rate. But what about the initial fee? This is the initial fee, right? The initial fee is 70. So this is higher. That's not truth because this is lower in reality. This is lower than the 70. So we discard B. Let's find out C now. Electrician A has an initial fee that is less than that for electrician B. So electrician A has a fee, initial fee. Oh, let's see. We had an electrician A with a fee of 50. Is that less than electrician B? Yes, because electrician B is 70. So 50 is definitely less than that. So far so good. The first sentence, that's correct. Now the hourly rate for electrician A is greater than that of electrician B. Let's find out. The hourly rate for electrician A is 25. That's the hourly rate for electrician A. And the hourly rate for electrician B is 20 per hour. That is truth also. This statement is truth, right? Therefore, C will be the correct answer. What about D? Why D is not correct? That's homework for you. Find out. Let's continue. We have now problem number 9. Problem number 9 right here. For problem number 9, we need to find out what is the slope of the line on a coordinate plane that passes through these points. that passes through these points. There are different methods in order for you to solve this problem. So I'll teach you both methods and you pick which strategy you like better, right? Which strategy you like better. So the first strategy that we can use to solve this is using the slope formula. And the slope formula, right? The slope formula, it's pretty straightforward, where we have changing y, right? The changing y over the change in x. Changing y over the change in x. Therefore, all we have to do is to label the points, plug it in, and we're going to be able to solve and find our slope. So let's do this real quick. First, we're going to label it. Remember, the first number is always x. The second one is y. First number is x, second number is y. You decide in which order you want to label the points. I always, the first point, label it 1. So x1, y1, and the second one will be x2, y2. So now all I have to do is to substitute, right? Replace it in the formula. So m is equal to y2, which is negative 2. So negative 2 minus y1, which is 2, divided by x2, which is negative 1 minus x1, which is 2. All right, we got our points. Now we know that negative 2, and I'm taking away 2, that will give me a negative 4. Negative 2, and I'm taking away 2, I'm going to get negative 4. Negative 1 minus 2 will give me negative 3. Now, this answer is not there. I don't see that exact answer here. I see 4 over 3 with 1 negative, but not 2 negatives. Right? I don't have the exact answer here. And this is a tricky question because a lot of students will pick A because they believe this is the right choice because they see the negative. However, we need to remember something very, very important. When you divide, right? When dividing a negative over a negative, we always get a positive. And this is the case. We're dividing a negative divided by a negative, and therefore we get 4 over 3. Right? We get a positive answer. Therefore, we already know that our answer is C. Is D. I'm sorry. The answer is D. This is our answer, D. Let me show you real quick the other method that you can use if you like drawing, for example. If you're a little creative and you have some time. So you can draw a little quick Cartesian plane, right? A coordinate plane. And you can quickly, right? You can quickly locate these points. If you're good at doing this and you have an idea where the points are located, you can do this. And this is pretty straightforward because I know this is 1, I know this is 2, I know this is 1, this is 2, right? 1 and 2. You don't need to label more points because these points are really small, right? So 2, 2, where is this point located? 2, 2. 2, 2 will be right here. You see it? That's my first point, 2, 2. This is x and this is y. This is negative y and this is negative x. So 2, 2 is my first point, is right here. Now I need to plot the next point. Negative 1, negative 2. This is negative 1 right here, and negative 2 is right here. So this is my second point. And I need to find what is the slope that connect these 2 points. I need to find what is the slope that connect, right? There is a line that goes through these points. There is a line that goes through these points, and I'm trying to find the slope. That is a very easy way to do this. If you get to do the drawing, pretty easy to do. All you have to do is to count by rise over wrong. Rise over wrong. How many times do I need to go up to be at the same level of this point? Let's see. I am a negative 2, remember? So I need to go 1 unit, 2 units, 3 units, and 4 units. You see, I went up 4 units. You need to go up 4 units. Up 4, right? You went up 4 units. Now, I went up 4 units. I am right here. I'm standing right here. Let me put an X. I'm standing right here at this point. Now, I need to run. I need to go to the right to chase that point. I need to get there. So, how many units do I need to go, right? I am in negative 1 right here, right? How many units? 1, 2, because this is a point, 2, and then 3. So how many units did you run? You run 3 units. You run 3 units. Therefore, the slope will be 4 rise over 3 that you run. I hope this is clear. Let's continue immediately with our next problem. Problem number 10 right here is asking me about the radius of a sphere, right? And we have a cone as well that we need to compare. We need to select the expression that represents the difference in volume in cubic inches of the sphere and the cone. If you are good at drawing, it would be nice to draw. If you don't know how to draw, it's alright, you don't have to. These formulas are given to you. These formulas is given to you. There is a little sheet, a reference sheet with these formulas. This is the formula to find the volume of the sphere. This is the formula to find the volume of the sphere, and this is the formula to find the volume. This is the formula to find the volume of the cone, right? Pi r squared h, right? We have our two formulas right here. What we need to find out is the difference between them. Now, something that you notice immediately is that both of them have pi in common, right? They have pi in common. They have r in common, of course. They do have r. However, r have different exponents, and they don't have h in common. But pi, they definitely have identical pi in common. Something we can do immediately is to, like the answers represent, we can take pi out of the equation, right? Pretty much we put pi somewhere here, and then let's find the difference between them, right? We factor pi. We factor it out. We say, no, pi and pi, okay, you can go here, because whatever the difference I get, is pi is going to be the difference. So now we try to find the difference of them, and all we have to do is to substitute, right? We have to substitute. We have to replace r, which is our radius, right? And our radius is given to us. We have the radius of the cone, which is 3 inches, and we have the radius of the sphere, which is 4 inches. Therefore, this is the sphere and this is the cone. So let's find out. 4 over 3 r to the third power. What is the radius of the sphere? 3 to the third power. And therefore we have on the other side, I'm sorry, 4. The radius of the sphere is 4. It's not 3, it's 4. And then on the other side, we take it away, right? Because we're finding the difference. The difference would be 1 over 3. And then what is the radius of the cone? Is 3 square. And what is the height of the cone? Is 8. We can see the height right here is 8. Now we do some basic computations here, or we can stop here and look for our answer, because our answer was not solved. Which of this expression matches our expression? The volume of the sphere minus the volume of the cone. Right here we can see 4 over 3, 4 to the third power, minus 1/3, 3 squared times 8. This and a are identical. Therefore, this is your answer. This is the answer for the sphere and the cone. I still want to do the drawing real quick, right? This is a little bit like a sphere, and the cone should look something like this. And remember, the radius is in the center, right? R. I just wanted to do the little drawing for you so you can visually see it. Let's continue. Now we have problem number 12. Problem number 12, we have an equation here, x cubed, right? Cube, or x to the third. X cubed or x to the third. And we need to find out which of these numbers is the value of x. Which of these numbers is the value of x? In order for me to find out which number is the value of x, we need to understand what is this, the cube root. And let me tell you something real quick. We know that the opposite or inverse, remember, inverse operations, right? We know that the inverse of adding is taking away. The inverse of subtracting is adding. The inverse of multiplying is dividing. The inverse of dividing is multiplying. We already know these 4 basic operations, correct? And this is how we solve equations pretty much. However, there is another one. When you have something square or something cube, then the opposite is the square root of that. So let's say we have x squared. The opposite of x squared will be a square root, right? Whatever you have a square, the opposite will be a square root, because there is an invisible 2 right here that cancels out with the square. Therefore, if we have x to the third, then we have cubic root. In this case, you don't have to write it down. The square, you don't write it down, but the cube, you have to write it down. So this is the cubic root. Cubic root, right? Cubic root. That's what we find. This one is a square root. So the opposite of something to the third power is the cubic root of that. So using this concept, we need to apply it to this particular equation right here. X to the third, right, or x cubed is equal to 64. So what about if I do, like I told you, the x cubed on both sides? So x to the third and x to the third. Now this will cancel with this, and I have my x by itself, right? I already have my x by itself. Now I need to find the cubic root of 64. What is the cubic root of 64? The calculator that you have may be able to process this, but if it doesn't, it's okay. It's pretty easy. What we are finding is which of these numbers right here in the list, when I multiply by itself 3 times, will give me 64. Remember, it's the same concept when something is a square, right? Let's say you have 4 square, for example, right? For example, you have 4 square, so this is 4 times 4. So 4 times 4 is 16. So that is 4 squared. 4 squared is 16. That's an example. In this case, we're finding something that multiplies instead of 2 times, 3 times. So it will be, for example, it will be 4 to the third power, for example, will be 4 to the third power, right? 4 cubed will be 4 times 4 times 4, because it has to be 3 times. 3 times, 1, 2, and 3. Now, what do we get when we multiply 4 times 4 times 4? Let's find out if this is the answer, right? 4 to the third power. 4 times 4 times 4. What is 4 times 4? 4 times 4 is 16. These two right here are 16. And then we bring this down, right? 16 times 4. How much is 16 times 4? 16 times 4 is 64. Oh, 64. Therefore, my answer is 4. Because 4 to the third power will give me 64. Let's continue. We have more problems. Now we have problem 18. Problem 18. This is a beautiful graph that we need to understand. We need to understand what is happening in this graph. We're given an equation right here. We're given an equation y equals 0.3x plus 5.8. So we already know 5.8 is the y-intercept. We can see it right here in the graph. This is the y-intercept, right? This is the y-intercept, and we already know that 0.3 is our slope. Remember, our slope, y equals mx plus b, right? Y equals mx plus b. Now, this is the line that best represents this relationship between what? Between alligator's weight, right? Alligator's weight and their growth, right? How much they grow over time. So this is the time in weeks, and this is the weight in pounds. The time in weeks and the weight in pounds. Now, which statement best? This is the key word right here, and it is bold. You see it? And it's in bold. Which statement best describes what the number 0.3 represents? What is the meaning of the slope? What is the meaning of that number right there? And this is what we need to find out. This is what we need to fully understand. What is the meaning of the slope? 0.3. So we need to put this into context. Usually, the way that I explain this is that per every week, right? That's how I use the slope for that you can fully understand it, right? And it's always the same case. Per every, that's the key word right here. Per every what? Week, because this is measured in weeks, right? Per every week, what happens to the weight of the alligator? As you can see, we have what kind of trend? What kind of trend do we have? We have a positive association here, right? We have a positive association. We have a positive trend, correct? We have a positive trend. It's going up. It's increasing. It's increasing in the x-axis. It's increasing in the y-axis. Therefore, I can conclude with the following statement. Per every week, right? Every single week, 1 week, remember, 1. Per every week, the weight, right? The weight of the elevator, right? The weight, which is in pounds, right? The weight of the alligator, because this is what we're measuring, the weight of the alligator increases, because that's what is happening, right? It increases by how much? By how much do you think it increases? It's talking about pounds here, right? So it will increase by 0.3 pounds. 0.3 pounds. That's the key here to understand this particular problem, right? Every week the alligator increases 0.3 pounds. That is the meaning of the slope. And therefore, we need to find out which of these statements make sense. The starting weight in pounds, the starting weight, no. The starting weight, we already said that the starting weight is the y-intercept. So we discard this. This is not describing, like this number 0.3 is not describing the starting weight. The starting weight is 5.8, right? This is wrong. In reality, the starting weight is 5.8. It's right there. It's the y-intercept. Now, B, the approximate number of pounds the alligator gains each week. The approximate number of pounds the alligator gains each week. That's exactly the statement I wrote down here. This is the approximate number because it's not exact. It says best described, right? It says best described. So the approximate number, what is the approximate number of pounds the alligator will gain every week? 0.3 pounds. This is the approximate number that the alligator will gain. We're finished with this problem 18. Now, it's time for us to use some tracing paper. We have here a trapezoid, right? I hope you can see it clearly now. We have a trapezoid, and the trapezoid is labeled ABCD. As you can see, the original one is the one without primes, remember? Is the one without primes. A, B, C, D. This is the original one. And the ones that you see that have primes is because a transformation took place. Something happened. Something happened to it, right? Something happened. So if we have the original vertices, right? The original vertices, this is how we call the corners of any figure. In this case, it's a trapezoid. And then we have the little prime here. That means it was transformed. Something happened to it. Now we're going to find out what kind of transformation happened here. What was the transformation that took place in this particular one, right? Because maybe it was just this one, or maybe more transformation took place. And that's why we need some tracing paper, as I showed you at the beginning. Right here I have a piece of tracing paper. We're going to use it right now. Which series of transformations could be applied to map trapezoid ABCD, the original, remember, you can call it the original, onto trapezoid A prime, B prime, C prime. So what transformations can happen to go from here to here, right? Go from here to here. Now, you might think immediately, wow, this was reflected, and that's it. Okay. Now, is this one of the options? That's what we try to find out. Is this one of the options? Do we have this in the options? That's what we need to find out. So let's start understanding the answers. Reflection over the x-axis. Okay, we're going to reflect this over the x-axis, so right here. And then we're going to rotate it 180 about the origin. And then we're going to land here. Okay, that may work. You have another reflection over the x-axis and then a rotation of 90. I don't think a rotation of 90 will get you there, because if you rotate 90, you usually land on the next quadrant. Remember, these are called quadrant. This is quadrant 1. This is quadrant 2. This is quadrant 3. And therefore, this is quadrant 4. Roman numbers, by the way. So when you rotate 90 degrees, you usually land, like if you use 90 counterclockwise, you're going to end up here. If you use 90 clockwise, you're going to end up here, right? This is usually what happens when you rotate 90. So we can discard answer B because it's not making sense. And then we also can discard D because it's also talking about a 90-degree rotation. So let's start testing A. Let's follow A. Let's see what A has to do with our answer. So the first step is, if you are given tracing paper, of course, in the test, or at least you can practice with tracing paper, is to draw the original, right? We have to draw the original, and that way we can do our transformations, right? So let's immediately plot the vertices, then connect the lines real quick. We connect the lines. After I connect the lines, since I am reflecting over the x-axis, I need to draw this axis as well. So I need to ensure that this axis is also drawn. So by the way, I gotta do this, right? I gotta do this because I'm rotating about this axis right here. So I need to do this because this is the axis that I'm reflecting. Reflecting, right? This is the axis that I'm reflecting about. So therefore, if I'm reflecting over the x-axis, right? If I'm reflecting over the x-axis, all I have to do is to take this paper and flip it like this. And therefore, this line that I draw here, you align it with the axis. And ensure that these points match. They are in the same line. They need to match. You see? These points need to match. Correct? So right here, these points are exactly in the same line. Then you make a little dent. You make a little force, like you push it a little bit, you push it a little bit, you push it a little bit, and then you have our points there. Here we have our points, and then you draw it, right? You draw it. There you go. There you go. It doesn't have to be perfect, but you get the idea. You draw it. Now that you have it, what you have to do is follow the next step. We reflected over the x-axis. We did it. Check. Now it says rotate 180 about the origin. Okay, let's go. This is our rotated figure, the blue shape that you see here, right? Or cyan. Now that we are here, we need to rotate it about the origin. This is the origin right here. How do I rotate this 180 about the origin? Remember, when you rotate it 180, it doesn't matter if it's clockwise or counterclockwise because you're going to land in the same position. So what we're going to do is to hold the pencil on the origin, right? Hold the pencil on the origin right here. This is the origin. With one hand, we hold it here, and then we rotate it now. So if I rotate this like this, this is 90 degrees. This is not what I've been told. I've been told 180. This is 90 degrees. So we continue all the way, another 90, and there you go. We have our rotated figure. We have our rotated figure right there. And therefore, our answer is A. Now, let me tell you something real quick before we move on. I want to emphasize that this figure right here, we always need to label. We always need to label the points, right? Because this is something I missed to do. You always need to label the points, right? This is A, this is B, this is C, and this is D. So that when you perform the transformations, right? When you reflect it, you know where the points are. And then when you rotate it, right? Then when you rotate it, you also know which points are which. You see? This is A. Let's take a look. Oh, that's A prime. This is B. This is B prime. This is C prime, and this is D prime. So you see that they match, and it makes sense for this one to be our answer. Let's move on real quick. 20 right now. Question number 20. This is an easy question, to be honest, because you don't actually have to do any work. All you have to do is to explain which one is a linear function. Linear. Right? Which one will graph and give you a straight line. And you already know what is the equation of a line and a straight line, right? Y equals mx plus b. Pretty much you are finding which of these right here looks like this, exactly like this. And I'll give you a little hint. Whenever you have x and the exponent is 1, so it's invisible 1, remember? You label it. So this is invisible 1, so the first one has the first power. But whenever you have something that is raised, right, this is a straight line. Let me give you some examples, right? We either got a positive line or we can get a line with a negative slope, right? We can get two examples right here. A positive slope, positive m, or negative m, right? Positive slope or negative slope. Good, excelente. But now, if you have an equation where the exponent of x is 2 or 3, in this case is 3, right? This is a square, this is cube. Whenever the exponent is higher than 1, like in this case is invisible 1, remember we don't write it down, but it's invisible 1. Whenever you have exponent that is a square, you are going to get a parabola. You're going to get a parabola, right? Either facing up or facing down. You're going to get a parabola. Therefore, our answer is straightforward. It's A, because this is the one that has exponent that is 1 and looks exactly like this one. You see, we don't have this. We don't have y mx squared plus b. No, that doesn't exist. It doesn't exist. It's not real. It's not happening. It doesn't make it happen, right? So this is what happens. I hope these concepts help and that you fully understand. Let's move on to question 22. Question 22 is one of those questions that is very conceptual, that pretty much what you have to do is to understand what is happening. Understand the problem and what is happening. We have some keywords here in the problem, right? We have triangle ABC. We know it's been rotated in a specific direction, but we have a keyword right here, right? Rotated 90 degrees clockwise, and it says here that it was dilated, right? Dilated. When something is dilated, it's like this. We have a small triangle, and then we have a big triangle, right? Or even we have a small and we can get a smaller one, right? Because this is a dilation, right? This is when something keeps the shape, right? You keep the same shape, right? Same shape and same angles, right? Same shape and same angles, but it's dilated. It's just changing the size. You understand? It's changing the size, but the angles are the same and the shape looks exactly the same. However, the other concept about this particular problem is which figures are congruent. In order for a figure to be congruent, it has to be pretty much exactly the same. That's what congruency means. If I have a rectangle and I have another rectangle and they both have the same measurement, let's say this is 2, this is also 2, let's say this is 4, this is also 4, then these are congruent because they have the same measurements. These are congruent figures. But if they are dilated, then they are similar, right? They are similar, but they are not exactly congruent. So therefore, if we read the statement here, they are similar and congruent. Come on. If something is similar, it's similar, this is similar, but they're not congruent, they're not the same, because this is the keyword, same, sameness, right? Sameness, that's the keyword right here. They are similar, but not congruent. Okay, I like that statement. The shapes are similar, but they're not congruent, because you can rotate these triangles, you can do whatever you want, you can have whatever scale factor you want, right? You can make it bigger, you can make it smaller, but they are not going to be the same, right? They are not going to be the same, but they're going to be similar, but not the same. This is our answer. This is our answer, because they're going to be similar, but not the same. Now, they are the same, but not similar? That statement doesn't even make sense at all. They are the same, but not similar? That doesn't really make sense. They are neither congruent nor similar. Oh, none of them? Okay, so that means that you have a triangle that looks like this, and therefore suddenly you rotate it and you dilate it, and maybe it became a rectangle. That's what the statement is telling you right here. This is what this statement is telling you. Let's move on immediately to problem 23. Problem 23 is a very straightforward problem, and it's connected to a problem that we reviewed earlier. Remember, we reviewed a problem earlier where we did, right, that we wrote the statement that the triangles have 180 degrees. Remember that? We mentioned that, right? We mentioned the 180 degrees, right? Whatever the angles are, whatever these angles are, it has to add up to 180. So one of the angles of the triangle measures x degree. Okay, let's label it. One of the angles measures x. Another angle of the triangle measures y. Okay, this one measures y. One measures x, one measures y. Which expression represents the measurements in degrees of the third one? So we got to find out this one, right? We got to find out the third one. So I already know this is measure x and this is measure y. So if I add them, x plus y plus 180, does that make sense? If I add this and 180, that the sum of all of them has to give me 180. So the sum of all of them has to give me 180. So this is some number here, this is some number here, and this is some number here. When I add them all, it's supposed to give me 180. So we can write an expression. We can write that x plus y, right? X plus y is equal to 180. We know that, right? I'm sorry, x plus y plus something else, right? X plus y plus question mark, right? Question mark is what we're finding. The question mark plus x plus y is equal to 180. I know that the sum of the three angles, right? Three angles, right? The sum of these three angles have to give me 180. The sum of these three angles have to give me 180 degrees. So which expression of this will make sense? Which expression of this will make sense? It's only A that makes sense, because A is 180, which is the total, minus the sum of the other two. So 180 minus these two will give me this one. But if I do 180 minus x, in reality, I'm just doing 180 minus one side, and then I'm adding the other side. That is not correct, right? That is not correct. It's supposed to be, the parenthesis is extremely important here. That's the key part. The parenthesis is explaining that you need to add the other two first in order for you to find the third one, right? You do 180, which is the total, minus these two, right? Minus x minus y, right? You do 180 minus both of them, and then once you do all of that, you will get the question mark. You will get the question mark. All right, let's move on because we have more problems. This is problem 27, and this is a very straightforward and easy problem. This is very easy problem. So which expression is equivalent to 3 to the 5th? Interesting. 3 to the 5th. Which expression is equivalent to 3 to the 5th? Now, one thing you can use is the calculator. You already know it. You can use the calculator simply, and you put in the calculator 3 to the 5th power, right? And then you will find out how much will that give you, right? This is pretty much 3 times 3 times 3 times 3 times 3. 5 times, right? 1, 2, 3, 4, 5. And therefore, you're going to get a number, right? You're going to get a number. And that number, whichever of these give you that number, that's the answer, right? That's the shortcut explanation. However, what this particular question is testing is what is called exponent rules. What are the rules of exponents right here? What are the rules of exponents right here? This is the key right here. Exponent rules. Therefore, when we are dividing according to exponent rules, right? When dividing, we must subtract. Remember, we must subtract the exponents. That's the rule. When dividing, we must subtract the exponents. That's what we do when we're dividing. Who can tell? Who can tell what happens when we are multiplying then? When we multiply, what do we do with exponents? We add exponents, right? We add exponents. But in this case, we're dividing because all of them are divisions. So let's start with the first one, with A. 3 divided by 3. So that will give me the same base because that's one of the rules of exponent, right? That will give me the same base. So let's apply the rule. When dividing, subtract the exponents. So the bases stay the same, which is 3. That's the rule. And then we do 10 minus 5. 10 minus 5. What is 10 minus 5? That's 5. So 3 to the 5th power. And therefore, A is our answer. That was pretty easy. A is our answer. But we can check B real quick, right? Same base, right? We're going to get the same base. 15 minus 3. 15 minus 3 is 12. That's not correct. 10 minus 5. That also give me 5. However, since the numbers are different, the numbers that we're dividing, that gives me slightly different answer. So we have a different rule here. Because we cannot use the same base when they have when they're different bases. We cannot apply the same rule, right? So this is going to give me a slightly different answer. So this is in reality 9 to the 10 is the same as 3 to the 20, right? 3 to the 20. So I reduce this by half, but then I increase this by double, right? I multiply this by 2, divide this by 2, and then I still have 3 to the 5th here. And therefore, since I have the same numbers, now I can keep the base, and 20 minus 5 will give me 15, right? So there are two methods. You can use a calculator, or you can understand the rules of exponents. 30. Problem number 30. This is our last problem of this first session. And we are asked here which of these numbers, right, could represent in this list, right? Which of these numbers could represent the side lengths of a right triangle? Which of these can represent the side lengths of a right triangle? Keyword right here, right. So you can do a little drawing real quick if you like to draw. So a right triangle means I have 90 right here. That's 90 degrees. That's a right triangle. And we're trying to find out which of these will represent a right triangle. This is a concept pretty much of Pythagorean theorem, where the theorem of Pythagorean theorem establishes that c squared is equal to a squared plus b squared. And I will explain to you what that means right now. So C is always the longest side, pretty much the diagonal. C is this side right here, and A and B can be any of this. A can be this or A can be this. It doesn't really matter. So we can keep the order and write A here. So A, B, and C, right? A, B, C. But it doesn't matter. B can be located here and A can be located here. Now, what the Pythagorean theorem establishes is that the sum of these two, right, the square root of the sum of these two, a square, will be able to give me this length right here. So we need to find out which one satisfies this equation. Which of these satisfy this equation? And all we have to do is to replace it, right? Replace it. So we decide to get the numbers, right? So we can say you are A, you are B, and you are C for each of them. Right? You are A, you are B, and you are C. So let's just try the first one, right? Let's try the first one. So 13 square. So 13 square is equal, right? C square, right? C square, which is 13, is equal to A square, which is 5 square, plus B square, which is 10 square, right? Which is 10 square. Is this truth? It's 5 plus 10 equals to 13 square. Nope, this is not truth. So we discard that one. Let's do B right now. 17 squared is equal to 5 squared plus 12 squared. Very interesting. 17 squared is equal to 5 squared plus 12 squared. Is this truth? No, this is not truth, because if you put it in the calculator, you'll find out you'll get different answers, right? Same as this one, right? You'll get different answers. Even if you add these two, you get 15. Even if you add these two, you get 17. This is a tricky question, because you may think, oh, if I add these two, I get 17. Nope, this is a tricky question, so this is not correct. And we can put it in the calculator. You know, you can be sure and confident by putting in the calculator. What is 5 squared? That's 25. What is 12 squared? That's 144. Okay, 25, 144. Now, what is 17 squared? That's the key word. What is 17 squared? 17 squared is 289. And 289 will not give me this, because the sum of these two is 169. So 289 is not the same as 169. Now, let's find out C now. Let's check C. C will be 26 squared equals to 10 squared plus 24 squared. Okay, this is an interesting problem here, because we need to find out if it really works, right? We need to find out if it really works. So we do the same thing. We find out what is 26 squared, and we will find out that is 676. What is 10 squared? I already know this is 100, because it's a perfect square number, by the way. And what is 24 squared, right? What is 24 squared? That's 576. If you add these two right here, will you get the same answer? Yes, you will. You get 676. You get 676. Therefore, our answer will be C. This is session 1 of the state test exam from 2024.